Welcome back to the Deep Dive. For years, if you listen to the conversation around artificial intelligence, particularly, the creation of large language models, you heard one thing repeated louder than anything else: scale.
That's absolutely right. Scale, scale, scale.
The narrative was simple. It was almost like a law of physics for the digital age.
It was. The assumption was that progress required this relentless commitment to bigger chips, bigger budget.
Right. And larger, more demanding data centers. It was the AI arms race, where only the companies that could afford to spend these astronomical amounts of capital—
The brute force approach.
Exactly. Only they were considered true contenders for the frontier.
And that assumption was, it was baked into everything. Academic research proposals, venture capital investment theses. It was all built on this idea that frontier intelligence was just, inextricably linked to immense computational spend.
So if you weren't ready to drop billions on silicon and energy—
The accepted wisdom was you just couldn't play. You could not get competitive, cutting-edge results. The barrier to entry was simply the size of your wallet.
But every so often, technology delivers a plot twist.
And this is a big one.
And today, we are unpacking a monumental shift that, and I don't think this is an exaggeration, fundamentally changes the physics of this competition.
I agree.
Our deep dive today centers on a revolutionary advancement coming out of China, specifically from DeepSeek and their newly launched DeepSeek V3.2 model.
It's not just, a product launch. It feels more like an architectural gauntlet being thrown down.
A gauntlet. That's a good way to put it.
It forces everyone in the industry, from the biggest tech giants to the smallest, most nimble startups, to really reassess their strategy, their investment, even their core philosophy on how you build these models.
And here is the core revelation. This is the piece of information that's driving this whole discussion and honestly should genuinely stun you.
Okay.
DeepSeek V3.2 is reportedly achieving performance parity with what we currently understand about OpenAI's GPT-5.
Which is the frontier, the absolute peak.
But here's the kicker. It is accomplishing this feat using only a fraction of the computing budget that we've always associated with models of that caliber.
This is a declaration that the old scaling laws, they aren't immutable.
They can be broken.
Or at least bent. It challenges the assumption that the relationship between input resources and output intelligence is a simple, linear trade-off.
So it's not just more money in, more intelligence out.
No.
Yeah.
It strongly suggests that a huge amount of the computational power we've been using up until now was based on, frankly, deeply inefficient designs. They found the ultimate efficiency hack, and it proves that smarter architecture can trump sheer scale.
So our mission today is straightforward. We're going to unpack not just what this model does, but why this radical new standard of resource efficiency is the critical variable. This isn't just a technical win for DeepSeek. It's a strategic game changer that redefines the traditional paradigms of AI development, and it impacts everything from global investment to sustainability. And it directly affects how you, the listener, should view the future of this entire field.
We really need to spend time establishing why this efficiency breakthrough is so critical. Like we said, it's not merely about saving money.
Right.
It impacts global competition, it lowers geopolitical barriers, and it fundamentally rewrites the rules for who gets to innovate at the frontier. By prioritizing optimization, DeepSeek V3.2 is challenging the very notion that the future of AI is reserved solely for, an exclusive club of trillion-dollar companies.
Okay, let's unpack this central technical achievement. The headline is, it's immense. So let's start with the benchmark.
Right.
DeepSeek V3.2 is matching the performance of OpenAI's GPT-5. We need to be clear about what we mean by using GPT-5 as the standard, because that represents the current, or at least the near-term gold standard of what these large language models can do.
And when we talk about frontier performance, we are defining a very specific set of high-level abilities. It's not just about, producing convincing text anymore.
No, the bar is much higher now.
It means excellence in complex, multi-step logical reasoning. It means high-fidelity performance in code generation and debugging.
Which is huge for enterprise.
Huge. A strong capacity for mathematical problem-solving, and increasingly these advanced capabilities in planning, retrieval, and domain-specific knowledge integration. We're talking about achieving that top-tier quality and that breadth of capability.
So performance parity means that for the user, the experience, the quality of the model's answers, its overall utility. It's all comparable to the most advanced models out there.
And that's the goal.
But the journey to achieving that parity is where the revolution lies. It's about getting that maximum result with a vastly reduced input cost.
I like to think of it like a global marathon.
Okay.
Previously, the winning strategy was to build the world's most powerful engine and just use the most fuel, burn through it.
Brute force.
Brute force. DeepSeek V3.2 is showing that a hyper-optimized engine can cover the same distance at the same speed, but use, say, a tenth of the gas. The resources spent to train that initial model, the entire expenditure of effort, time, and hardware, are just significantly lower.
And this brings us directly to the metric that quantifies this cost reduction.
Yes.
Fewer training FLOPs. We cannot stress enough how fundamental this metric is, especially for anyone listening who might only be familiar with, consumer electronics metrics.
Right, this isn't gigabytes or megapixels.
No. FLOPs, floating point operations, are the ultimate unvarnished measure of computational cost in training these massive models.
To simplify it, a FLOP is essentially one single step of a mathematical calculation that a chip performs.
One step.
One tiny step. But when you train a model like DeepSeek V3.2 or GPT-5, you are performing calculations not in the millions or billions, but in the trillions, sometimes even quintillions of operations.
It's a number that's hard to get your head around.
It is. And the cumulative total of these FLOPs determines everything. How many GPUs you need to run in parallel, for how long, and crucially, the resulting energy consumption and financial cost. It is the direct measure of resource usage.
So when DeepSeek V3.2 achieves top-tier performance, but uses significantly fewer training FLOPs,
it implies a fundamental and non-trivial breakthrough in efficiency. It's not a small tweak.
And this is where that old paradigm is shattered. For years, the reigning philosophy, rooted in the famous scaling laws, was simple.
More is more.
More is more. The total number of FLOPs you dedicate to training is the single best predictor of your model's final performance.
Yeah.
More FLOPs meant better models, period.
And that model led to a predictable and, frankly, a resource-wasteful design philosophy.
Which was?
The dense model approach. These dense models, common in the first generations of LLMs, were designed so that every single parameter in the model was involved in every calculation for every single token process.
So everything is firing all the time.
All the time. They were computationally heavy, highly redundant, and they maximized the FLOP count simply because, empirically, that's what worked to drive up intelligence. It was the only tool they had.
But DeepSeek V3.2, by achieving parity with fewer FLOPs, suggests they found a way to make their architecture inherently more. What? Knowledge efficient.
That's a perfect way to put it. They are extracting the equivalent intellectual quality from a much smaller input of raw compute.
Which immediately leads you to speculate on how they're doing it, right?
Yeah.
Even without them releasing all the proprietary details.
Oh, absolutely. When a model dramatically reduces its FLOP requirement while maintaining quality, the industry immediately looks to techniques like sparsity and, more specifically, mixture of experts architecture.
MOE. Let's delve into that because it provides a fantastic visualization of this efficiency breakthrough.
It really does.
So in the old dense model paradigm, you said every worker in a factory contributes to every step of every product built.
Right. It's slow, it uses a ton of energy, and it's not specialized at all.
Okay, so what's the MOE factory look like?
In a NOE architecture, which DeepSeek V3.2 is very strongly speculated to be using, the model is split into several expert subnetworks.
So like different departments.
Exactly. When you input a prompt, the model uses a router network to decide which one or two experts are most relevant to the task. It might send it to the coding expert or the creative writing expert.
And only those experts turn on.
Only those few chosen experts wake up and perform calculations for that specific request. The rest of the model stays dormant.
So the genius of this approach is that you can build a model with a massive number of total parameters, say trillions, which gives it a huge breadth of knowledge.
Right.
But only a small fraction of those parameters are active during any given task.
And that is the computational parsimony we keep mentioning.
Parsimony. I like that.
You still have a massive intelligent model, but you are not paying the FLOP cost of that entire massive structure for every single operation. You're achieving a huge capacity for knowledge, the same size skyscraper, but you are calculating with significantly less physical effort per operation. You are effectively avoiding all these redundant calculations that dense models are forced to perform.
This shifts the competitive edge dramatically.
Completely.
Previously, if you wanted a smarter model, you had to simply buy a bigger supercomputer.
Yep, more GPUs.
Now, the smarter model is achieved through intelligent architectural design. The advantage moves from pure capital expenditure, who can afford the biggest GPU cluster, to intellectual expenditure.
Who can design the smartest, most resource-thrifty MOE router and expert system? That's the new race.
You can almost hear the strategy meetings changing in rival labs globally, can't you?
Oh, I'm sure of it. For years, their R&D was focused on optimizing the deployment of these existing, fundamentally inefficient, dense architectures. How do we get more out of them?
I know.
Now they must pivot overnight to become experts in sparse modeling, in MOE scaling, and finding ways to make the training process itself inherently more efficient. Learning to extract maximum knowledge per FLOP.
It forces everyone to confront a difficult question.
Mm-hmm.
Was a significant portion of the hundreds of millions, maybe billions of dollars in energy dedicated to training previous frontier models just wasted on inefficient designs?
The answer that DeepSeek V3.2 seems to provide is likely a resounding yes.
Wow.
And if we look at the historical implications, this is profound. Every single technology race that hits a resource bottleneck, whether it's physical size, material cost, or power consumption, eventually has its breakthrough defined by efficiency.
Right.
For AI, DeepSeek V3.2 looks like that defining moment. It redefines the new paradigm. Optimization, architectural ingenuity, and efficiency are now equally, if not more, crucial than sheer expensive scale.
That technical understanding of MOE and reduced FLOPs leads us directly into the strategic so what?
The consequences.
Exactly. We're shifting from the engineering achievement to its global economic and competitive consequences. And for the last several years, the AI development landscape was, let's be honest, an oligopoly. It was dominated by tech giants.
Precisely. The resource requirements, the astronomical cost of acquiring and maintaining thousands of these state-of-the-art GPUs.
Not to mention the cooling.
The cooling infrastructure, the perpetual energy bills, it all acted as this incredibly high, exclusive wall. It protected the incumbents.
It was their moat.
It was their moat. It ensured only those few companies with trillion-dollar market caps and these deep geographic centers of compute could play at the frontier. This concentration of power became the status quo.
But the efficiency achievement of DeepSeek V3.2 it's like an explosive variable in that equation.
It changes the math completely.
If that, say, $50 million compute run that was required to test a frontier hypothesis can now be reliably achieved for $5 million or even less.
Then you see the profound democratization effect take hold.
And this is the critical aha moment for you listening.
It really is.
Lower resource needs translate directly into enabling entirely new classes of firms to innovate and compete.
Think about it. A small, specialized AI firm focused on, say, pharmacological research.
Okay.
They previously needed this huge capital injection just to train a foundational model capable of high-level inference. They had the scientific brilliance, but they were just financially throttled. They couldn't even get to the starting line.
But now, if the minimum viable budget for entering the frontier race drops by a factor of 10,
that specialized firm can now afford to iterate, to train, and to deploy models that are directly competitive with the largest players.
So capital is no longer the absolute insurmountable bottleneck.
It's not. Suddenly, ingenuity and architectural design and resource allocation, that becomes the new competitive edge.
But I do want to introduce a moment of friction here just to maintain some balance.
Sure.
While the barriers are dramatically lowered, we probably shouldn't overstate the idea that this throws the doors open to, true garage startups operating on shoestring budgets.
That's a very important clarification. $5 million or even $1 million for a cutting-edge training run is still prohibitive for a two-person team in a garage.
Right. This isn't the App Store in 2009.
No. This democratization likely benefits the second tier of global technology firms.
No. So who are we talking about?
Mid-sized companies, specialized industry leaders, state-backed entities, and ambitious, well-funded scale-ups. They're the ones who benefit most.
So instead of maybe 3 or 4 global contenders, we could now have 30 or 40.
Exactly. And that fundamentally challenges the current status quo because the giants, who relied on their scale and their ability to just absorb astronomical costs,
suddenly find their capital advantage significantly devalued.
Their moat is being drained by architectural breakthroughs. They used to be able to just outspend the competition until they ran out of compute time. Now the competition can just wait for a DeepSeek-style efficiency breakthrough and leapfrog them.
This forces a rapid strategic pivot for everyone involved. The prevailing strategy for years was acquire resources first.
Get the GPUs, build the data centers.
And then figure out how to use them second.
Right. The new strategy, dictated by DeepSeek V3.2, has to be Optimize your architecture first, and then minimize resource allocation based on those smart designs.
And this has immense implications for global competition, particularly when you think about geopolitics.
Oh, absolutely. For too long, the narrative suggested that resource dominance was the exclusive domain of a handful of Western tech firms.
Silicon Valley, basically.
Basically, this development, coming specifically from China's DeepSeek, signals a successful and profoundly disruptive alternative strategy. It proves that peak performance can be achieved via engineering excellence and efficiency, independent of overwhelming capital supremacy.
So this achievement acts as a global signal.
It's a flare going up.
It says you don't need to win the GPU purchasing war to win the intelligence war. You need a better blueprint.
Yes, and this empowers nations and large companies outside that traditional Silicon Valley sphere to accelerate their own AI capabilities rapidly. They can rely on indigenous engineering talent rather than just relying on importing high-cost hardware at volume.
And you should consider the implications for your own industry, whatever it may be.
Right.
If top-tier, frontier AI capabilities are suddenly cheaper and more accessible, who enters your specialized field?
Who's your new competitor?
Exactly. Companies previously blocked by the sheer capital required for high-end AI research, maybe competitors in India or Europe or Southeast Asia, suddenly become viable, formidable rivals.
It's a shift from a game of high-stakes poker where only billionaires could sit at the table.
To a game of chess,
Yeah.
where architectural brilliance and strategic optimization carry the day.
And the incumbents are now forced to play defense. They have to invest heavily to make their existing dense models more efficient, even while they're still training the next generation of their large, resource-intensive models. It's a two-front war for them now.
The competitive dynamic isn't linear anymore.
Not at all. It's now about discontinuous leaps based on these architectural breakthroughs. This model proves that intelligence can be the product of thoughtful design rather than just brute force computation. It introduces agility into a market that was previously defined by inertia and massive capital lock-in.
And this strategic pivot toward efficiency naturally leads us into where this conversation gets, I think, really interesting, which is the long-term, high-level implications for sustainability.
Yes.
When you talk about AI training, the financial cost is often front and center, but the environmental footprint is, well, it's enormous and often overlooked.
That's a critical point.
Yeah.
The computational demands of training these colossal models have astronomical energy requirements.
Yeah.
We are talking about data centers consuming the power of entire small cities.
For months at a time.
Just to perform the necessary training calculations over months, DeepSeek V3.2 offers a tangible, quantifiable path to mitigating this growing environmental crisis.
So let's connect the dots precisely between DeepSeek's technical success and this need for sustainable AI practices. The core metric is fewer training FLOPs. It seems simple, but if you cut the FLOP requirement by, say, 70%.
You are, in theory, cutting the energy required for training by 70%. It's a direct relationship.
And the numbers are staggering enough to justify this pivot on their own, right?
They really are. Studies that quantified the carbon footprint of training the first generation of massive models, like GPT-3, showed emissions equivalent to 5 average cars over their entire life cycle.
For one model training run.
For one run. Every single iteration and refinement of those models adds to that environmental burden. The industry cannot sustainably continue to scale models linearly if it results in exponential growth in power consumption and carbon output. It's just not viable.
So DeepSeek V3.2 isn't just saving the company money. It's providing a blueprint for a future where AI, a technology that's critical for solving global problems, doesn't end up exacerbating the climate crisis.
Right. If AI adoption continues without optimization, its growth will inevitably hit regulatory, political, and literal energy walls globally.
So this efficient architecture is kind of an elegant technological end run around that impending problem.
I think so. And it also drives intense resource allocation scrutiny far beyond just energy.
Meaning the hardware itself.
The hardware. We are operating in an environment of perpetual global shortages of specialized hardware, primarily high-end GPUs like the NVIDIA H100s or their successors.
They're like gold dust right now.
Exactly. These chips are finite, they're expensive, and they're critical to all sorts of national and commercial interests, including everything from defense research to pharmaceutical discovery.
So when resources are this scarce, Efficiency moves from being just a desirable feature.
To an absolute necessity. If DeepSeek's MoE-style architecture can achieve the same performance using fewer GPU hours for training, it directly frees up those scarce resources for other essential tasks.
Like commercial inference or fine-tuning or...
Or accelerating innovation in entirely different sectors. This capability to stretch the finite pool of hardware is a major strategic advantage.
How so?
Well, if a company can train 5 competitive models where it previously trained 1, it exponentially accelerates its speed of innovation simply by being smarter about how it deploys its capital hardware.
So the limited global supply of AI compute goes further.
It goes further and delivers more value, rather than being inefficiently locked up in training unnecessarily dense models.
This forces the broader industry, and I mean everyone, from data center operators to government regulators, to reevaluate the wastefulness that we've often associated with this brute force AI scaling.
Absolutely. The pressure is now immense on all major developers to justify the vast resources they consume. If DeepSeek has proven that you can be highly intelligent and radically efficient, then the lack of optimization becomes a competitive, financial, and frankly, an environmental liability.
Have we seen this kind of shift before in other tech sectors?
We have. A great historical precedent is the transition in chip manufacturing from bulky, high-power consumption chips to smaller, more power-efficient mobile processors.
Right, for smartphones.
Exactly. Necessity forced optimization, and the efficiency gains unlocked an entirely new, massive market, mobile computing. We are seeing the same inflection point here for large-scale AI training.
And this sustainability imperative creates a kind of powerful feedback loop, as we touched on earlier.
It does.
Efficiency drives democratization because models are cheaper to build and deploy.
Which drives a wider range of architectural experimentation as more diverse minds enter the field.
And that experimentation inevitably leads back to further efficiency gains.
So sustainability in this context, it's not just a moral obligation. It is a profitable, beneficial side effect of the economic pressure to be smarter and more agile.
The era of simply throwing hardware and money at the problem and, hoping the scaling laws will save you
is over. The expectation has been set by DeepSeek V3.2. Optimization is now a mandatory feature of frontier AI development, not an optional tuning knob.
And the ability to deploy high-performing AI responsibly, meaning sustainably and cost-effectively, is now what will define who leads the next decade of development.
I believe so.
So DeepSeek V3.2 delivers this profound triple win.
It really does.
It maintains top-tier performance, it drastically reduces the cost to achieve that performance, and critically, it increases the overall sustainability of the entire AI enterprise by demanding fewer FLOPs.
That combination is why the single model release is revolutionary and why it merits this level of detailed analysis. It's not just a technological improvement, it's a total redefinition of the economic model of AI.
We have covered extensive ground today, moving from the technical details of FLOP reduction and MoE architectures to the strategic reshaping of global competition and the environmental necessity of optimization. Let's bring this all back and summarize the key takeaways for you, the listener.
The central overriding message is that the immense resource barrier that has guarded the frontier of elite AI is, well, it's fundamentally breaking down.
It's crumbling.
It is. DeepSeek V3.2 demonstrated performance parity with the highest caliber models like GPT-5, but accomplished this using dramatically fewer training FLOPs. And that fundamentally changes the cost structure of high-end AI development.
And this singular achievement, it doesn't just benefit one company, it unlocks these profound systemic shifts.
Right.
It fuels democratization by lowering the minimum viable budget required to compete at the frontier, allowing a wider range of ambitious firms and nations to enter the race.
And as we just discussed, it mandates a critical pivot towards greater environmental sustainability in an increasingly resource-constrained world.
So the current status quo, which was defined by a few resource-rich incumbents, is being challenged.
And it's not being challenged by a larger hardware stockpile, but by architectural ingenuity. The competitive edge has decisively shifted from who possesses the largest capital reserves to who fields the smartest, most resource-thrifty engineering teams.
So what does this all mean for the future trajectory of AI? It means the AI arms race is changing its definition of victory. It's shifting investment and focus away from pure firepower, which is defined by resources and scale,
to genuine intelligence, which is now being defined by efficiency and optimization.
This puts the incumbents, the firms that stake their entire future on the linearity of those scaling laws, in a fundamentally difficult position.
A very difficult position. If high-performance AI is no longer exclusively owned by those with the deepest pockets and the largest hardware stockpiles, the competitive landscape has been radically reshaped.
So the market leaders who spent years optimizing only for raw speed or maximum size while neglecting efficiency.
They are now playing an intense game of catch-up to redesign their core architectures.
The era of the dense brute force model is over. The era of sparse, smart, and sustainable AI is here.
It is.
And that leads us to our final provocative thought for you to consider, something for you to mull over as you digest these strategic shifts and watch the market react to this new resource paradigm.
If the next breakthroughs in artificial intelligence are defined by architectural efficiency and computational parsimony rather than simple resource magnitude, which traditional tech giant, the one that historically relied most heavily on its immense capital advantage, its massive data centers, and its perpetual GPU procurement to maintain market leadership, is now the most vulnerable to disruption by agile, specialized firms focused purely on optimization and MOE architectures.
The firms that clung longest to that bigger is better mantra may find themselves the least prepared for a world where smarter is faster and vastly cheaper.
I think that's right.
The efficiency revolution has arrived, and it will favor the clever, the agile, and the resource parsimonious, not just the wealthy.
Thank you for joining us for this deep dive. We look forward to exploring the implications of this shift with you further.